Thank you everyone for joining us. We are the Nebraska Academy for Methodology, Analytics, and Psychometrics, also known as the MAP Academy. And we are housed within the Nebraska Center for Research on Children, Youth, Families, and Schools, also known as CYFS. Today is the last of our 2021 methodology application series. So this year, our series is really focused on considerations and novel approaches for measuring different types of latent constructs. Today we have Dr. Lorey Wheeler, who's Research Associate Professor for CYFS and co-director of the MAP Academy. And she's going to talk to us about measuring dyadic relationships. But before handing the presentation over, I want to congratulate Dr. Wheeler on having just received our college's Emerging Scholar Research and Creative Activity Award. So thank you, Dr. Wheeler, and go ahead and take it over.
Thanks, Natalie. And thanks everyone for coming today to hear me chat about dyadic data. It's one of my favorite topics, so hopefully I won't go too overboard, but anyway, I'm gonna focus on today in particular how we might go about measuring relationship constructs using dyadic data via dyadic indices. So I'm planning on presenting for about an hour with time about we should have hopefully about a half an hour for any of your questions. So we'll just hold all of your questions until the end. So I'm gonna go ahead and see if I could figure out my screen sharing stuff here. Give me just a second. All right, awesome. So just to give you an overview of what I will be talking about today, the goal really first is to give you a broad overview of some of the key issues that you have to think about when using dyadic data. I will then introduce methods for measuring dyadic level indices that capture constructs such as similarity and dissimilarity in dyads, patterns of influence in dyads. The approaches to measuring dyadic indices that I will highlight will both include composite variable approaches and latent modeling approaches. So my talk today is really meant to serve as an introduction to these topics. So I also provide a lot of resources throughout the talk and at the end for those of you who want more information. So to get us all on the same page, let's start with some foundations. So scholars interested in relationships, so married individuals, parent-child relationships, parent-teacher relationships, siblings, just to name a few. These scholars have long recognized the complexity and interdependent nature of these relational systems and processes. So to give you an example and to ground this talk in the relationship literature, theoretical frameworks that highlight the importance of interdependency really encourage scholars to examine both dyad members' perspectives and experiences in capturing the complexity of relationships nested within broader ecological contexts. So this quote by Kenny and colleagues nicely represents the utility and strengths of dyadic data. So the nature of our social science research questions are often inherently about relationships or multiple persons within a unit. And dyadic data really has the utility to provide nuanced answers to complex questions about systems and relationships. So this interdependence should be viewed as a strength and not a problem that has to be dealt with analytically. To make this concrete, here are a few examples of dyadic data. So both members in a relationship rate how satisfied they are or the quality of the relationship, providing perspectives from both members in the unit. Alternatively, two persons rate themselves on an outcome, target, or behavior. This can provide information about individual level and dyad level processes or mechanisms within the dyadic or that relational unit. So individual and relational functioning is related not only to the individuals themselves, but also to the complex system of behaviors between those members of the system. So similarity is one important representation of that complex system of behaviors between members. So for example, in family systems theory, it postulates that individuals within the same family system may share a common perception of the world, impacting those interactions within family relationships. And so assessments of similarity allow us to test this theoretical assumption. So how might you use dyadic indices in particular in research? So you can use them to understand how similar or dissimilar dyad members are to one another. You can do this by using similarity or dissimilarity scores to predict other variables, or use other variables to predict levels of similarity between the pairs. So there are both manifest and latent variable approaches to creating this type of index. And you can also test hypotheses about constructs, for example, such as complementarity, the influence of shared environment on dyad member similarity, the influence of shared views on relationship quality, or understanding the pattern of mutual versus individual influence in a relational context. So let's dig a bit deeper into non-independence. So what this means and the important issues in relation to analysis. So another quote, Gonzalez and Griffin make the point that often researchers go to the effort of collecting data from both members in a dyad, but then often don't know how to approach or handle the interdependence of the data. This often results from the courses we take in graduate school, right? So the basic analytic methods we learn in many of our statistics courses primarily focus on those methods that have that assumption that the sample units are independent. So even in courses which address non-independence, such as multi-level or hierarchical modeling, they may not address the dyadic research designs, and there are some specific unique aspects to these designs that I'll get into. So as you might expect, right, dyadic data violate that assumption of independence. So Kenny and colleagues suggest that for these linked scores, the dyad members are more similar to one another than they are to people who are not part of that dyad, as with nested data designs, right? So that similarity of the dyad members is that aspect that's violating our assumptions of independence of units within our research. Another unique aspect of dyadic data, right, if we're thinking about hierarchical or multi-level modeling, right, that level 2 cluster size, our level 2 units and our level 1 units are important, and the size of those, the sample sizes for each of those units is important in multi-level modeling. So with dyadic data, right, we have that cluster size of 2, which is less than what is needed for traditional multi-level or hierarchical modeling approaches. So, right, you have on the one hand, approaches for independent units don't work, and then traditional approaches for modeling interdependence also may not work in their traditional fashion. So you have to alter these methods to work more accurately with dyadic data. So in thinking about where does this non-independence come from, right? We can think about those voluntary linkages, friends, dating partners, parents. So parents and teachers, right? So the parents of students and those linked teachers. We also have kinship linkages. So family members, right? They include shared genetics and environments. In experimental linkages, which we may not think of as often, but relationships can be created in a laboratory setting or in a study. So for example, you may ask two persons to get to know each other within the context of an experiment. So then we are creating interdependent data. There may also be what's called a yoked linkage. So two individuals never interact at all and are not aware of each other, but are exposed to the same environmental stimuli. So as we think of these linkages, they can be combinations of two or more types of linkages. So married couples are linked voluntarily and by kinship. So this is just to give you more of that context of how we might go about thinking about dyadic relationships. So once our dyad members are paired, even if the pairing is random, so we basically have it so that these compositional effects are unlikely. There are then three processes that may produce non-independence between two individuals. So there's something called a partner effect. So this occurs when a characteristic or behavior of one person affects his or her partner's outcomes. So for example, the amount of housework that one roommate does may and probably does affect the other roommate's level of satisfaction with their living arrangements. We also have what's called mutual influence. This occurs when both persons' outcomes directly affect one another. So mutual influence often includes a process of feedback. So for example, in a study of initial interactions between strangers, mutual influence might occur for liking. So for example, so that the more a person likes his or her partner, maybe the more that partner likes the person in return. So it's an example of mutual influence. And then there's also what is called common fate. So common fate effects occur when both dyad members are exposed to the same causal factors. So consider again that roommate example. If their apartment complex is poorly maintained and the environment is unpleasant, then the two roommates' satisfaction might be similar because of the unpleasant environment affects both roommates. So this is just kind of thinking about and contextualizing this non-independent nature of our data. So, as we're thinking about the dependent nature of dyadic data, scholars, of course, argue that we shouldn't make these four errors when working with dyadic data to answer relational questions, right? We can't assume that these units are independent. So meaning we just ignore that non-independence and treat all observations as if they were independent, right? We know that's all kinds of wrong. There's also something called a deletion error. So we go about creating independent data by throwing out half of our sample. So for example, we just don't use husband's data, or we use husband's data and not wife's data. We choose one partner and then go about describing the relationship from that partner's perspective, right? So we're really losing the richness and perspective of both dyad members, especially when we're trying to understand a relationship. There are also cross-level errors. So when we create independent data by taking the average of the dyad for each variable, so this can mask differences and variation within the dyad. And then we have the level of analysis data, error. So where we might go about interpreting correlations of dyad level averages as a dyad level process, and interpreting correlations of individual observations as individual level processes. So these both ignore the inherently dependent nature of the data and may be conflating individual level and dyad level variance included in both of these means and observations. So I'll be talking about indices that can more accurately measure, right, this interdependence between dyad members. Okay, so another key kind of foundational construct when we're thinking about and working with dyadic data is what's called distinguishability. So distinguishability has to do with the question, can dyad or group members be distinguished from one another based on a meaningful factor? So why does this matter? So analysis procedures really depend on whether the members of the dyad are indistinguishable, or sometimes called exchangeable, or not. So dyad members can be distinguished if there is a variable that allows the researcher to differentiate members that is theoretically or analytically meaningful. So for instance, members of heterosexual couples can be distinguished by gender, right? That's one factor that could distinguish those members. Really why this matters is because when we're doing the analysis, a systematic ordering of the scores can create different results. So say you just randomly placed husbands and wives into member 1 and member 2, kind of ignoring the important factors that distinguish husbands and wives. This would create very different results, as you can imagine, then by acknowledging that these dyad members can be distinguished by theoretically meaningful constructs. So a systematic ordering of those scores from the 2 dyad members should be developed based on a variable that distinguishes them. But there are cases when dyad members aren't distinguishable. So in that example of roommates, right? So if the roommates are of the same gender, how would you know who dyad member 1 is and how dyad member 2 is? So there are approaches for that type of data. Today, I'm really going to be focusing on what I'm calling distinguishable dyads. So those dyads where there is a theoretically relevant or empirically relevant factor that can distinguish members. So just a little bit more on why distinguishability matters. If you, as I was suggesting on the last slide, distinguish dyad members in an arbitrary fashion, right, the results from this analysis would vary if the data were ordered differently. So it is inadvisable to treat members of the dyad as distinguishable when in fact they are not. But just because members can be distinguished, such as by gender, does not mean that this distinction matters in the case of your particular research question. So many dyadic data scholars do recommend testing, empirically testing whether that factor is relevant in the context of the research question being asked. So for example, if husbands and wives, right, can be distinguished by gender, but say that gender does not affect their responses. So then in that case, right, you test empirically. If gender isn't mattering in that situation or in relation to that research question, it would be better to not make then such a distinction. And by testing empirically whether or not these factors matter, I think we can really contribute to and add to the literature. Right, so in the case of husbands and wives, maybe in the context of your research, it's really age that matters. So who is older within the couple, and maybe you're not even thinking of age. So I think if you can think of these factors and theoretically kind of come up with reasons why you might think they matter and then go about testing them, then I think that's a stronger way for proceeding in relation to distinguishability. When you're creating the indices that I'm going to be talking about, really this matters in how you might be kind of structuring your data in your data set, right? So if you have a data set with husband variables and wives variables, right, that inherently is assuming that gender is important within how you've ordered your data. So then when you're creating these indices, that member 1 and member 2 distinction can play a role in what you might see. Okay. So I do want to talk about one particular type of research design that can be used with dyadic data. So this type of research design is called a matched pairs design. So matched pairs design are probably the most common approach that is used in the literature. I mean, it's very standard. About 75% of dyadic research uses this type of approach or research design. There are other designs that you can use. For sake of time today, I won't be touching on those, but I can provide references for those other types of designs. So in a matched pairs design, it's really common, right, when you're trying to understand interpersonal processes. So in this approach, you collect data from the two yoked dyad members with a one-to-one match, right? So you can see here in my figure, in each dyad, there's a person 1 and a person 2, and they're in that one dyad. So each person is unique to only one dyad. So we have person 1, person 2, person 3, person 4. These are all unique individuals within unique dyads. So in the standard design, dyad members report on the same variable about themselves or about a relationship. So for example, parent-teacher relationship quality should be in this design reported on by both teachers and parents reporting on that relationship. In contrast, right, the data are not reciprocal, so this wouldn't really count as a matched pairs design if both parents and teachers are reporting on the role of parents in that relationship, right? You would want parents and teachers both reporting on their own role or on the other's role in the relationship. So that is just a slight nuance in this design. And many studies can include different kinds of data collection, but in order to create the dyadic indices that I'll be talking today, you want the dyad members to be reporting on that same relationship in order for these to work. So the inherent interdependence in this type of research design, of course, poses those unique analytic challenges that I've been talking about. And so as we're thinking about these designs, again, we're really thinking about the dyad as our unit of analysis and not our individual. So our sample size would be the number of dyads, right? As we've been talking about, because these members of this dyad are interacting or they're related in some way, they're not independent units. Okay, so that kind of got our foundations out of the way. Now that we're on the same page with these, let's dig into how to measure dyad level indices. So the primary goals of dyadic indices is really to provide a way to quantitatively measure non-independence within the dyad unit and to use that resulting number or quantity of non-independence to inform our understanding of relational phenomena, right? So this could include what might relate to this non-independence, what this non-independence in the dyad might relate to. So there are a number of different indices that you can produce in the context of dyadic data, including similarity and dissimilarity indices. You can also use different approaches to create these measures. So you can create manifest or composite variables. You can also use latent variable modeling approaches. So I'll talk about all of these different types of indices. So first, let's start with manifest or composite variable approaches. So when we're thinking about indices, I'm going to start by talking about dissimilarity. So in many of these slides, you'll see that I reference the Dyadic Data book by Kenny and colleagues. That's a great reference for those of you who want to dig into dyadic data approaches. And so in Kenny and colleagues' book, they note several common dyadic indices. So indices measuring both similarity and dissimilarity. So as we're talking about these, they may seem very similar, right? It's just a different aspect of similarity. But when you're conceptualizing these and then actually quantifying these measures of similarity and dissimilarity, we go about creating them in different ways. So indices of dissimilarity in particular include something called discrepancy. So in this indice, we're summing the absolute difference between member scores, and then we're dividing by the number of measures. There's also the d squared, right? The sum of squared difference between the measures. There's a measure called distance, which is the square root of d squared. So really all of these measures are trying to get different aspects of agreement conceptualized as how different they are, right? So you're trying to understand their agreement or disagreement on the average level of the scores, the shape or pattern of the scores, and also the spread of the item responses. And so when we consider these measures of dissimilarity, this kind of multiple aspects of agreement that you can examine. In addition, you can also calculate these measures regardless of whether dyad members exhibit variability in their responses across items. So kind of given these qualities, some scholars argue that dissimilarity indices have more utility than similarity indices. So I'm going to talk about similarity indices next, but then I'm going to come back to dissimilarity indices in more detail in relation to the latent variable modeling context. Okay, so I just said similarity, maybe not as great, but let's still talk through similarity measures. I think they can be useful depending on what your questions are. So measures of similarity allow for the consideration of, again, that agreement or relative similarity of dyad members. So they include measures such as correlation, covariation, and interclass correlations. So most of you are probably familiar with these measures. In this instance, we're really thinking of them as, thinking about the two members within the dyad and then creating these indices by either correlating the scores within the dyad. So dyadic indices of similarity provide, an alternative way to measure the non-independence that exists within dyads. So these indices can be positive, so a positive number, which suggests the relative similarity between dyad members, though counterintuitive, but as we all know, measures of similarity can also be negative. So capturing when two members are relatively different from one another. A couple of examples of when negative non-independence can occur. So if you think about the construct of compensation, so when one person has a large score, the other person may have a lower score, So we have in this dyad, a person with a high score and a person with a lower score. And if we're thinking about compensation, theoretically, this could occur, for example, if one person is overly friendly in the dyad, maybe the other person is responding or reacting by being more distant. So understanding this dyadic context of compensation can provide useful information, for example, So this is an instance when understanding this similarity or non-dissimilarity or non-similarity can be important in understanding a mechanism within a relationship. Another example of this is social comparison. So this might occur when dyad member scores are determined based on the relative difference in relation to another measure. So to make this concrete, an example might be that the level of satisfaction for the dyad members after a tennis match is determined by who won or lost that tennis match. So as you can imagine, the person who lost may feel less satisfied, whereas the person who won feels more satisfied. So in this way, right, similarity can be useful to help us understand things that are going on in a relationship. So if we think about the correlation coefficient in the context of dyadic data, a simple correlation can measure how dyad member scores on a given measure increase and decrease. So it measures the correspondence between the relative rank orderings of the scores. But the correlation does not provide information about the actual level or spread of the responses, right? So for a given measure, a wife could have scores of 1 and 2, and a husband could have scores of 4 and 5, yet their responses could be perfectly correlated. So a correlation and covariance indices are not sensitive to differences in level, and they may not be sensitive, and they are not sensitive to differences in spread. So correlations, right, if you're thinking of a correlation as a similarity measure, it's really about the score variability and not the similarity in the values themselves. But if you're interested in variability, this can provide you with an index that can be useful. Now, if we think about the representation of similarity of scores, the interclass correlation can capture how much of the actual score rather than the variance is the same for the members of the dyad. So if you look here, right, that the first bubbles where mother and father are not overlapping, right, are ICC as a -1. And from that, right, there's no similarity in those scores. An ICC of 0.3, there's some slight similarity with that kind of sharing in the middle. An ICC of 0.75 might suggest, right, there's pretty high similarity in those scores. So the interclass correlation coefficient is a standardized metric that represents how much of the underlying score is shared by members of the dyad. So in other words, the ICC represents how close each partner's scores are to one another, which can be a useful way to think about similarity. So scholars argue that the interclass correlation coefficient is an effective measure of similarity. The ICC takes into account the similarity between two individuals and the value of their scores, rather than just the correlation between their scores. So many of you who have heard of the interclass correlation, maybe you've heard about it in the traditional context of a measure of inter-rater reliability, right? So it's another way to think about the score, and we're now applying this to the context of dyadic data. The ICC is also recommended given that it can be adjusted for stereotype accuracy. So what do I mean by stereotype accuracy? So in thinking about our ICCs, right, it's important to note that members of a dyad may also be similar to one another because they share views held by most people or a large proportion of people in a group or a population. So two randomly selected individuals might have a degree of similarity in their responses just because of the cultural context that they're living in. Right? So if, for example, most people would probably respond in a fairly similar fashion to questions about their acceptance of domestic violence, right? But in dyadic and family research, we are usually curious if members of a dyad are more or less similar than would be expected by chance. So do spouses from a given dyad report more or less similarity than a randomly selected man or woman? So so you can adjust for this stereotype, right? If we think of it in that way. So to obtain the stereotype adjusted ICCs to get at that understanding, basically you're taking the mean for each item and you're subtracting that before computing your ICCs. So in effect, what you're really doing is making the ICC a measure of how similar the dyad members' deviation scores are. So Kenny and colleagues suggest that in analyses with distinguishable dyads, the group mean should be used to do this adjustment. So I'm not going to go into how you might go about creating an ICC. Lots of computer programs can create an ICC for you. But this is just giving you an example how you might go about adjusting that ICC. And you can use the ICC. So once you've created the ICC and then adjusted it, if you're interested in that piece of it, you can then output the ICC into a variable in your data set and then use it as an independent, dependent, or moderator variable to try to understand questions of how does similarity relate to other constructs, or what is predictive of more similarity in perceptions, or do variables have a stronger or weaker association based on the level of similarity in the dyad? But of course, as with all of our approaches, there are some methodological limitations of the ICC. So first, given the manifest nature of the computation of the ICC, it really does assume that the factor structure of the measures are similar for both members of the dyad. So what do I mean by that? So if dyad members interpret the items differently, this may affect their similarity score. So ICCs, so in a manifest, as with any manifest or observed variable or a composite variable that we're creating, right? This, you can't adjust for that. That's an assumption that's inherent to this type of approach. Also in this type of approach, as with other composite variables, you can't compute this when there's missing data. I mean, of course, you can take appropriate approaches to adjusting for the missing data. So using item level data that you've imputed through a multiple imputation context, or using full information maximum likelihood, right? You can use those approaches, but these are just things that you have to think about if you're using the similarity index of the ICC. Okay, so I really wanted to spend most of the remaining time talking about latent variable modeling approaches. So I'm going to start by talking about what are called latent congruence or latent difference models. So these models, right, as we're thinking about operationalizing congruence, so this idea we've been talking about, agreement, fit, similarity, right, as you might imagine, this has been challenging given the limitations of creating manifest composite measures. So different scores and similarity indices, such as the ICC, they have been commonly criticized as having lower reliability than their components, so those items that make up those indices, and for disguising their contributions of the components on the dependent variables. So there are promising alternatives that use structural equation modeling approaches. So I'm kind of offering these two contexts, right? Depending on what's feasible in your research or what research questions you might have. I think you can take either of these approaches, but it's always good to know kind of the limitations that you're working with, but also the strengths of each of the approaches that you're using. So as with, right, kind of the structural equation modeling approach in general, it does offer advantages in relation to structural equation modeling, right? So I'll talk about these here in a minute. But to give you a couple references, Newsome and Chiang, they both talk about these structural equation modeling approaches, but I'm thinking of this as a difference index or a dissimilarity index, right? So there's what Newsom calls a latent difference model and Chiang calls the latent congruence model. But basically, when you look at the parameterization of these models, they're doing exactly the same thing. Right, latent congruence difference models, as you might imagine, are given that they're within the structural equation modeling framework. They're using latent variables to capture aspects of the dyad, right? So the index, we're now moving it into the latent variable modeling context. So these approaches can measure a couple of different things. So one parameter that you can get in these models is basically the latent mean or the absolute level for the construct that you're interested in. So it's basically the average rating of that dyad construct. So an example might be the average rating of relationship quality across parents and teachers. These models also measure that dyadic difference, or you can think of it also as congruence. So how different are teacher and parent reports on the quality of their relationship? And so these models are appropriately using the dyad as the unit of analysis and are accounting for that non-independence within the dyad. So the advantages that I was alluding to, right? So given the manifest variable approaches that we just talked about, structural equation models in general, right, control for measurement error. We know measurement error can produce biased estimates of the strength of our associations. So these models, in the simplest form, you can exclude measurement error, but in a full structural equation modeling model where you're including both a measurement and a structural model, you are adjusting, right, for that measurement error. Second, measurement equivalence, right? So I had alluded when I talked about ICCs that it's important to understand, are we measuring the same construct for both dyad members? So we can test measurement equivalence within the context of these models. And this is important for congruence, given that it involves the comparison of those component measures. So what is the difference of teacher and parent reports on the quality of their relationship? If measurement equivalence cannot be established, then this can limit the meaningful interpretation of results from those cross-member comparisons in this instance. And then third, latent congruence or difference, however you're thinking of these models, it allows the examination of both the antecedents and the consequences of both the mean or absolute level of the construct and the difference simultaneously. So you can do this in one model, whereas you can't do this with indices such as ICCs or difference scores. Okay, so the fun stuff, right? So as you can see here, this figure is what we might think of as a structural equation modeling conceptual model. And so this figure here depicts the parameters of our basic latent congruence model. So just for illustration purposes, I just use kind of the simplest version of this model. Basically, here you can see the score for dyad member 1 is a manifest variable, that Y1, and then we have the score for dyad member 2, Y2. So it's really just using that composite variable of the construct that we're interested in here for purposes of illustration to make this kind of easier to grasp. And as with any structural equation model, right, you can extend this to include that measurement model. So the basic premise of the latent congruence model is to create these two higher order factors to represent the mean or the level and the difference are what I'm calling congruence here in this figure. And so these are for those two interdependent component measures. So the way that we go about this is by constraining parameters between the factors and the component measures to the specified values that I have here. So for those of you familiar with structural equation modeling, right, this hopefully is making some sense. For those of you who haven't ventured into the context of structural equation modeling, just bear with me. Hopefully, conceptually, you can understand what this model is doing. So in yellow, right, we have the level, which is referring to the dyad mean on that construct. And then in the orange, we have that congruence or the difference. So for each of our latent, so these are latent factors, level and congruence. For each of the latent factors, we have a mean and a variance. Oh, let me back up for a second. So in conceptually and thinking about what the level represents, right, it is, if you work through all of the equations, basically what it comes down to is an average, right? Y1 plus Y2 divided by 2. And then congruence, working through all of the math here, it's basically a difference score, Y2 minus Y1. And so that's given the parameters that we have embedded into this model. So now let me skip down to ML and VL, right? So that's the mean and the variance for the level. So those are representing, right, the mean of the factor that we're calling level, and it is representing the grand mean of the mean rating of Y1 and Y2. VL, that's the variance of the factor level, and it's representing the variance of that mean rating of Y1 and Y2. If we flip over to congruence, we have a mean and a variance again, right? So we have the mean of the factor congruence, which is representing the average difference between Y1 and Y2. And then our variance of congruence is representing the variance of that difference, right? And then we have a covariance between level and congruence. So we have also, you can see here those red lines, right? The line going from dyad member Y2, right? The level line, we have a line going to both dyad member scores, and you can see here that those are constrained. That's what that's what those ones are representing here. Those are constraints that we're putting on our model so that it's then producing that equation that I just talked about, the Y1 plus the Y2. Then we have constraints for congruence, right? The negative 0.05 and the 0.5. These are basically the way that we're kind of working around to get that latent congruence factor to represent the difference in the scores. Okay, so to give you a concrete example of how we might use this or answer a question using this different score model. So using data from the Juntos project, my colleagues and I examined within couple factors that predicted discrepancies in Mexican origin spouses' marital negativity. So we found that high levels of wives' marital negativity linked to more discrepant reports of marital negativity within couples 5 years later. We also found that high levels of husbands' marital negativity related to more similar reports of marital negativity within couples 5 years later. So you can see this example is a little bit more complex than the simpler version, but it's basically getting at those questions, right? Those constructs that I talked about. So you can see that it estimated the couple mean and then the within couple difference. And so what that gives us above and beyond a more traditional approach to analyzing this data by looking at the within couple difference, we were able to understand husband and wife's predictors and how they varied in the predictors of that within couple difference. So, right, those wives who had high levels of marital negativity, 5 years later, the wives and the husbands were more discrepant in the reports of marital negativity. So that tells us something interesting versus for husbands that had high levels, who started with high levels of marital negativity, over time, right, those spouses and those couples became more similar in their reports of marital negativity over time. Okay, so I know you probably have questions, so I look forward to hearing. But here's another example just to give you an idea of how to use these models. So using that same model, we used data from several randomized control trials examining the efficacy of conjoint behavioral consultation. And we examined what factors relate to dyadic congruence between parents and their children's teachers' reports of parent-teacher relationship quality. We found that parents' level of educational attainment and teacher beliefs about parental involvement in education, each related to quality of relationship communication, right? So if we're trying to understand, we know that parent involvement in education is important, but that relationship between parents and teachers is also important. And so this is a way to try to understand that relationship by looking at that. Here we termed it congruence because the prediction, right, these high levels predicted there was less, we were finding that there was less difference in those reports given the predictors that we were looking at. So we were interpreting it as congruence. Okay, so lastly, my last topic, I'm going to talk about another dyadic index that measures interdependence patterns within dyads. So again, within the latent variable modeling approach, this is another way that we can capture interdependence. So this approach uses the actor-partner interdependence model. The APIM is a well-known analytic approach within the dyadic research space, and is probably the most used approach to modeling dyadic data. And this approach integrates a conceptual view of interdependence with appropriate statistical techniques for measuring and testing that interdependence. So specifically, these models are designed to account for the non-independence that may emerge between individuals who spend a lot of time together via 3 types of effects. So these effects are called actor effects, partner effects, and then they have also this dyadic index, which is capturing patterns of interdependence within the dyad. So I'll talk about each of these in turn. So here's a path diagram of, again, a simple APIM model. As I talked about with the difference model, the APIM can be extended to include all of the features of structural equation modeling. So if we look at this model, X1 and X2 are the independent variables for dyad member 1 and dyad member 2, respectively. And Y1 and Y2 are the dependent variables for each dyad member. Now, when we're thinking about an actor effect, this refers to the extent to which an individual's independent variable relates to their own dependent variable, as depicted by those orange paths there that you can see that are denoted as A1 and A2. So in all of these models, right, they also include C1 and C2 here, right? We're basically correlating the variables within the model. So for X1 and X2, we're correlating those 2 variables to represent as another way of capturing or telling the model that these are interdependent, and then E1 and E2, so the error terms were also correlating. So partner effects, right? That's another aspect or another effect that these models produce. So here in the green paths, you can see that the partner effects are demonstrating the relationship between an individual's independent variable and their partner's dependent variable and vice versa. So it's basically answering the question, how do two people influence each other's outcomes? So then the third effect or parameter that you can capture within the context of the APIM is this dyadic index, which captures what Kenny and Letterman and colleagues call interdependence patterns. So this dyadic index, which is referred to as the K parameter by Kenny and Letterman, it captures patterns of influence within the dyad, or who has more influence on whom. The K parameter represents these dyadic patterns, or what is driving the associations between the variables under study to gain greater confidence about specific patterns of influence that characterize dyads. So I'll talk about each of these patterns in turn. So what do these patterns represent conceptually? So an actor-only pattern occurs when there is the presence of actor effects for either or both dyad members, and there is also the absence of partner effects. So you can see that here, I used my cats as the members here, but if you think of the pictures on the right as the path model, we see that there are only effects from member one, or my cat Izzy, to her own outcomes, and then for member two, or my cat Billy, to her own outcomes, right? So this is suggesting that within the dyad, it's really an individual or an actor-driven process. A couple pattern occurs when there is the presence of significant partner effects in addition to actor effects for either or both dyad members. So overall, this pattern is indicating a focus on the couple or the dyad above and beyond the individual. Lastly, the contrast pattern occurs when the actor and partner effects are significant, but in the opposite sign. So this pattern is suggesting that the process works differently whether you are examining the actor effects or the partner effects. So how do we operationalize this K, what is called the K parameter? So the K parameter, it's a ratio. So you're basically taking the partner coefficient divided by the actor coefficient for each dyad member. Right, so if we remember back to that original path diagram that I showed, we had those paths, A1 and A2, and then P1 and P2 to represent those path coefficients. You're basically just taking the P1 coefficients and P coefficients and dividing them by the A coefficients. And so how you do this within the structural equation model is this parameter is estimating what's called a phantom latent variable, which are latent variables without disturbance terms to force linear constraints on the model. So the constraints allow for the quantification of these patterns of influence and statistically test these patterns, whether they're equal to 0, 1, or -1, right, given that ratio. Just one thing to note, in order to be able to estimate what's called the K parameter, you really need actor effects that are non-trivial, as recommended by Kenny and Letterman, meaning that they should be greater than 0.10. Okay, so evidence of the actor pattern is supported when the ratio of that K parameter is approximately equal to 0. So mathematically, this suggests that the estimate for the partner effect is near 0, right? So that's that coefficient that's on the top, right, of that division. So when K equals 0, that is evidence of an actor pattern. evidence of the couple pattern is supported when the K ratio is equal to 1. So this suggests that the actor and partner coefficients are close to the same. And then evidence of the contrast pattern is supported when the signs of the actor and partner effects are both in the opposite direction, resulting in K equal to -1. And so, right, you employ these constraints to the model, you can get these estimates of the K parameter, and then ultimately the last step is you're going to then constrain those parameters for each dyad member to 0, 1, or -1 to determine, does this fit the data, yes or no? And so you can get tests of that can support evidence of these patterns beyond just looking at the patterns of the coefficients. So here's my last example where we used this approach in the MOMI project. So we examined the development of ethnic racial identity over time for adolescents and their mothers. And we found evidence of the couple pattern for this one particular example. So that was evidenced by the K parameter being close to 1. So you can see there K is equal to 0.70. We also constrained it to 1 to see if that fit the data. And we found evidence that it did fit the data. So how we might interpret this is that during the process of ethnic racial identity development, and specifically for the component of affirmation, which refers to the positive feelings about being part of an ethnic racial group, both mothers and adolescents are influenced by what's happening in the dyad above and beyond individual processes. So hopefully that gives you lots of things to think about in relation to dyadic indices. I'm going to stop there and ask what questions that you might have. I also have compiled a bunch of different references, resources, and examples that will be, when we post the video of this, it will be included in that PowerPoint for you to reference later. So thank you very much, and I look forward to your questions.